Hey y'all, welcome to video number 1 of 3. We're going to be looking at solving systems of linear equations through graphing, substitution, and elimination. We're going to focus on graphing today. So open up your foldable to example number 1. Example number 1 says solve the linear system by graphing. Again, how you know it is a linear system is you have that x and that y to the power of 1, and also you have two linear equations stacked on top of one another. So anytime they give you a graph, always remember that the only way you are able to actually plot lines on graphs is if they are in your y equals mx plus b form. That is the easiest and the clearest way to be able to take any sort of linear line and graph it on a coordinate plane. So I'm going to look at these two equations individually because that's all system is looking at two linear equations, or it could be multiple linear equations at one time and trying to find something that they either have in common or don't have in common. So again, we're going to try to put these into y equals mx plus b form because I have this graph over on the right side. Now, if you have forgotten how to change this sort of linear standard function into that y equals mx plus b form, you can always remember the saying slide x divide y, or quickly just slide divide. Slide x divide the y. I'm so sorry for the focusing. This camera is still trying to work itself out. Okay, there it went. All right, perfect. So since we are looking at these individually, let's look at this x plus 2y equals 10. Okay, it's not in that y equals mx plus b form yet because that y is not isolated. It currently has an x and it has a 2 attached to it. So we're going to shift everything to the other side so that way y is completely isolated. So to do that, I have to slide x first. Slide x by doing the inverse operation on both sides. These x's cancel and I'm left with a positive 2y equals. When you rewrite the right side, always put your x first and then bring in that constant because that helps fit it to the y equals mx plus b form. Now I'm left with 2y on the left, so I've slid my x. Now I'm going to divide my y. 2's are going to cancel. I'm going to be left with that y equals, which is what we wanted. We wanted y to be completely isolated. And now I have this negative x over 2 situation. With that, we want to make sure it looks mathematically correct. And also, we want to make sure we can see that rise over run situation because we do have a graph over there on the right side. So I'm going to write that negative 1 over 2x. That way it's really clear that I have a rise of negative 1 and a run of 2, and then I have a positive 5 because simply 10 divided by 2 is a 5. Perfect. So I have satisfied that first line. We're going to come over here and graph it. The reason graphs work better with slope-intercept form is because, again, you have a slope and you have a y-intercept if it's needed. So let's go ahead and plot that. That y-intercept is at 0, 5. So 0, 5. And then to move this line from the y-intercept, we're going to go down 1 over 2. And for these, I'm going to go ahead and do a third point so that way I can make sure I understand. Down 1 over 2. And I do get asked a lot of questions, Miss B, can we go backwards? You absolutely can. Just when you go backwards, you have to remember, I need to stay in this negative formation here. So I can rise 1, but instead of going right 2, I would go left 2. Just so that way if you go that direction, you don't feel like you necessarily did it wrong, just understanding that you have to go backwards. So now I'm going to connect these lines. just like that. There we go. And then we are going to do the same thing to the other side. Now, if you want to pause this video and double check that you know how to slide divide on your own, I highly recommend, and come back. All right, welcome back. If you did pause, I'm going to go ahead and do this. 3x minus 2y equals 6. There we go. I'm going to slide that x. Those will cancel. I'm left with negative 2y equals negative 3x plus 6. Again, that fits that y equals mx plus b because the coefficient in x are first, then that constant is after. And then divide by my y, negative 2, negative 2. Those 2's will cancel. I'm going to have y equals. Now, negative and negative make positive, and 3 over 2 does not simplify. You can change it to a decimal, but again, I want to be able to see that rise over run, so I'm going to leave it as 3 over 2x. Now I have a positive and negative situation, so I am going to bring down a minus sign because just like my integer rules, positive and negative make negative when you're multiplying and dividing. Then simply 6 divided by 2 is 3. Going to do the same thing we did a while ago. Because all a system is 2 or more linear equations at one time, and you're just trying to decide what is going on this graph. So I'm going to plot that negative 3 just like that. I'm going to perform the rise and the run. 1, 2, 3 over 2. 1, 2, 3 over 2. And if you want to go reverse, you can. 1, 2, 3. Just make sure you go to the left instead. All of those ordered pairs are not necessary. I am just trying to show multiple different examples. So make sure my line is good and straight there. So now the purpose. The purpose, as some of you are probably already inferencing here, is I gave you two systems. We were able to slide and divide. We plotted both systems, and both of these equations crossed at one specific point. This is their intersection. Okay? And anytime they tell you to solve the linear, some sort of linear system, either it's graphing or one of the other two examples we're going to see, you're just trying to figure out what the graph has going on. And this one has an intersection at 4 and 3, it looks like. So that would be the solid answer, and this would be called a one solution. The reason for one solution is because they intersect at a singular point. Okay, so moving on to example number 2. Now again, I highly recommend you pausing and trying it on your own without me, and then coming back to the video. So at this time, go ahead and pause the video and you attempt example 2 on your own. All right, welcome back from your trial and error on your own. I hope it worked out for you, but let's see, going through the same process again, to solve the linear system by graphing. You know it's a system because you have one or more linear equations on your system over here. Now, there is something wrong with my systems. They are not in our y equals mx plus b form, and how I know that is necessary is because of the graph over on the right. In case you forgot how to do it, simple, slide x, divide y. Slide x, divide y. Perfect. Hopefully that is sticking a little bit better as we continue to do it more often. So we're going to take it one equation at a time. We have x minus y equals 5. Going to subtract that x. Remember, sliding, you can only do adding and subtracting, hence the slide part of it. Negative y equals negative x plus 5. This is where I see people get confused all the time, so I want to make sure I bring some light to this. Anytime you have a negative variable situation, you have to remember that mathematicians are lazy. There's an invisible 1 right there. The 1 is not necessary to write because by the y being there, it is implied. So you have to remember that if that y is negative, that is technically a negative 1, so you are not allowed to have that. Y equals mx plus b. Y is completely isolated, so you do have to still divide by a negative 1 under everything. So now my y is isolated, and I have negative and negative make, negative and negative make positive. So I'm just going to have an x right there. And then again, negative and positive make negative. And then I'll just have a 5. So essentially, anytime you divide by a negative 1, everything on the other side just becomes its opposite. X went from being negative to now it's positive. It went from being a positive 5 to a negative 5. Now we're going to go over here and graph it. I have negative 5 as my y-intercept. Now my slope. Again, you have a coefficient over here of a 1. So anytime that's the case, you rise 1, unless it's negative. You rise 1, run 1. Rise 1, run 1. And if you're fancy and you like to go backwards, down 1, left 1. Because we got to keep that positive formation. Sorry, I lost my ruler. Going to now draw my line. Want to try to keep your line as precise as possible so you get an exact answer here. Draw my little arrows, showing that that line's continuous. Then you do the same thing for the other equation. Get my pens out of the way. 3x plus y equals 3. Okay? Slide the x. 3x's cancel. I'm left with y equals negative 3x plus 3. Now, some of you might be thinking, Miss B, what about that positive sign? Just like in any rules in math, a negative has to be written, a positive does not. And along with that, this y is completely isolated just like it is up here. So there's no sense to divide at this step. We are completely done. I can now go over to the other side, plot my y-intercept at 3, go down 3, 1, 2, 3 over 1. I'm going to go ahead and do that one more time. 1, 2, 3 over 1. Connect my line. So sorry. You know me, I'm a perfectionist. I want it to be a straight line, just like that. Going to do my arrows. There we go. And as you can tell on the graph, we do have our intersection right here. There we go. There's our intersection. So anytime I say solve the linear system by graphing, graph your two equations first, figure out if they intersect. It might not always be the case, but on this one it was. So our solution is 2, negative 3, meaning that x is 2, y is negative 3, and this is a 1 solution. There we go. You know me, I gotta be bougie and put my little puffy cloud around it. Alrighty, I hope this video helps. See you in the next one.